All right, lesson on geometric sequences. We're going to start off. This front page here should be pretty much review on sequences from Algebra 1, but I know when I say that, a lot of you guys are like, whoa, I've never seen this before. So we're going to review it, it's really not that bad. First, recall a sequence is an ordered set of numbers called terms. There are two ways to define a sequence, explicitly and recursively. So we're going to go through the first half of this page is going through the explicit definition, and then there'll be the recursive definition. So the first thing you want to understand about an explicitly defined sequence is that basically it looks like this. Here's an example. And the n represents the number, the term it is. So a sub n, a subscript n, the n, if it's 1, it's the first term of the sequence. That's what that's saying here. So a1 is the first term of the sequence. Okay? a2, a sub 2, is the second term of the sequence. A sub 3 is the third term of the sequence, and so on and so forth. So if I say a sub 50, that's the 50th term of the sequence. Boom, 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 boom. So a sequence is, well, I guess I should give you an example of a sequence before we even do anything. What's a sequence? Here's a sequence. 2, 3, 4, 5, 6, da 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 da. It's just a list of numbers. Okay? So, and they could have any kind of pattern. You could have a sequence that goes like this. 3, 7, 11, 15, and so on. So what's happening? It starts with 3, and you keep adding 4 each time. Okay, so you guys have done this before. It's all about patterns. So consider the explicitly defined sequence a sub n equals 3n plus 2. So this is like the formula, or the way that you're going to get all the terms. They want you to write the first 3 terms of the sequence. So you're going to do a1, a2, and a3. So we're going to start with a1. a1, you're just going to plug a 1 in for n. 3 times 1 plus 2. And that's 3 plus 2, which is 5. So a1 is 5. Then you go and do a2. a2, a sub 2. It's a sub 2, but I'm not going to keep saying the sub. I just say a2. All right, so a2 is 3 times 2 plus 2. And that's going to be 3 times 2 is 6 plus 2 is 8. And then a sub 3, that's the third term, would be 3 times 3 plus 2. And that's 9 plus 2, which is 11. So this sequence goes 5, 8, 11. Those are the first 3 terms of the sequence. The first 3 terms of the sequence are 5, 8, 11. Okay? They want you to find a20. We can find the 20th term because we have this. We have the formula. So a20 is going to be 3 times 20 plus 2, and that's going to be 60 plus 2, which is 62. And then determine the 300th term, a300. So a300 is 3 times 300 plus 2, and that's going to be 902. Okay, so pretty simple. For explicit definition, you just plug in the term you want. You want the first term, you plug in 1. You want the second term, you plug in 2. You want the 90th term, you plug in 90. Very simple, and they're written that way. Now, a recursive definition is quite different. It's going to look different. It's going to look more complicated, but once you get going, it's really not that bad. Okay, so some things you got to know before you get into a recursive sequence. an represents the nth term. So it's the same as before. A5 is the 5th term. A21 is the 21st term. That's no different than explicit. But what you're going to start seeing in recursive definitions is this. Not so much this one, but this one right here. A sub n minus 1. So instead of a sub n, they put a sub n minus 1. All that means is the term before an. So think about that. If I have a8, and that's an, okay? Well, then isn't a7 a sub n minus 1? Because if n is 8, then n minus 1, 8 minus 1 is 7. Okay? So instead of using numbers, 8, 7, 6, whatever, they're going to use n and n minus 1. So whenever you see n minus 1, it just means the previous term. Just remember that. Whenever you see n minus 1, it means the previous term. So again, this should be review for you, but we're gonna do it anyways. So here is a recursively defined sequence. They have to give you the first term or a term. If they don't give you a term, you can't do anything else. So in this case, they give us the first term, a1 equals 3. Okay, that's great. I know my first term. How do I get my second term? My second term will come from the definition right here. So what is this saying? 2 times an minus 1 plus 1. 2 times an minus 1 plus 1. Put parentheses around that an minus 1. That an minus 1 is the previous term. So when you're doing the second term, it's the first term. When you're doing the third term, it's the second term. When you're doing the fourth term, it's the third term. It's always the previous term. Now, you might be a little confused right now. As we do it, I think you're going to see it. So here's the rule. 2, that's the 2 right there, times an minus 1. Now, an minus 1 is the previous term. Well, if I'm on the second term, the previous term is the first term, which was 3. So I'm going to plug a 3 in there, and then plus 1. Plus 1 is in the formula. 2 times 3 plus 1 is 7. So now I have my second term. My first term is 3. My second term is 7. My third term, a sub 3. Go back to the rule right here. I'm just going to clean this up a little bit here. Go back to the rule. 2 times the previous term. Now the previous term is 7. So 2 times 7 plus 1. That's what this means. 2 times the previous term plus 1. So I'm just going to put an arrow there. Previous term. Just remember that an minus 1 means the previous term. 2 times 7 plus 1 is 15. So now I know that a3 is 15. Okay, now I can do a4. A sub 4 is going to be 2 times 15 plus 1, and that's going to be 31. And then a sub 5 is going to be 2 times the previous term, which was 31. 2 times 31 plus 1, so that's 62 plus 1, which is 63. So a sub 5 is 63. So my first 5 terms are, I'm just going to change colors. My first 5 terms are boom, 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 boom. 3, 7, 15, 31, 63. Those are the first 5 terms of my sequence. Now, what's a geometric sequence? A geometric sequence is when basically everything keeps multiplying. So that here, that it was recursive, so it's not really arithmetic or geometric. But this here is an example of folding a sheet of paper in half. So Chuck folds a standard sheet of paper in half. Okay, so here is a sheet of paper. Sheet of paper. Okay? Right now it's one layer. If I fold it in half, it is now 2 layers. If I fold it in half again, okay, it is now 1 1, 2, 3, 4. It is now 4 layers. Okay? If I fold it in half again, it's now 1, 2, 3, 4, 5, 6, 7, 8 layers. So as you can see what's happening now, okay, let me go to green here. The sequence goes 1, 2, 4, then 8. Then what happens when you take the 8 and fold it in half again? There are now 16 layers, then 32, and then 64, and so on and so forth. This represents what's called a geometric sequence. Basically, you just keep multiplying by the same number each time. To get from here to here, you multiplied by 2. To get from here to here, it multiplied by 2. Here to here, multiplied by 2. Times 2, times 2, times 2. So R equals 2. R is the ratio that you're multiplying by. Okay, that's how a geometric sequence works. Now, there's explicit and recursive form for geometric sequences. This is what Algebra 2 is all about. Okay, so here is the geometric sequence, and here is, the explicit definition, and here is the recursive definition. All right, and it's very similar to what we just talked about. It's just going to be in this form, and you're just going to have to practice it to get used to it. So, basically, it's what we just did. Except now you're going to be having a geometric sequence. So, write the first, and I'm going to change this. We don't need to do 5 terms. We're just going to change this to 3 terms. So go ahead and make that change right now. Here is our definition. This is an explicit definition. So if they want the first 3 terms, they're going to plug in 1, plug in 2, plug in 3. So plug in 1, A1 equals 5 times, I'm just using the formula, 2 raised to the n minus 1. So it's 1 minus 1. N is 1. So it's 5 times 2 to the 0 power. And 2 to the 0 power is 1. 5 times 1 is 5. A2 is going to be 5 times 2. That's in the formula. And then 2 minus 1. So it's 5 times 2 to the first. 5 times 2 is 10. And then A3 is going to be 5 times 2 to the 3 minus 1. So it's 5 times 2 to the second. And 2 to the second is 4. 5 times 4 is 20. And look what's happening as we do A1, A2, A3. 5 goes to 10. Then 10 goes to 20. And then 20 is going to go to 40. A4 is going to be 40. Without even doing the work, you could tell what the pattern is. Why? Because the ratio is 2. Basically, this formula is taking 5, which is what you start with, and multiplying by 2, multiplying by 2, multiplying by 2, multiplying by 2. That's what this does. This right here. A1 is the first term, and then R is the ratio. So this formula basically takes whatever number you start with and then keeps multiplying it times the same ratio each time to get each term. So if you want A8, it's going to be A8 equals 5 times 2 to the 7th. It's always n minus 1. If you want A15, it's going to be 5 times 2 to the 14th. Why? It's n minus 1. It's always 2 times the one less than the term you're on. So it's going to be 5 times 2 to the 7th, and that one I already did. It's 640. I just did it to save time, and this one's going to be 81,920 would be the 15th term, because you just keep going times 2, times 2, times 2, times 2, times 2. All right, now some recursive, another recursive formula here. So this is I'm sorry, this is written recursively now instead of explicitly. So again, recursively, they gave us the first term, and then they give us the definition. They want to write the first 5 terms. So A1 is -4. A2 is going to be AN minus 1, that's the previous term, times 3. So it's going to be the previous term times 3. The previous term is -4 times 3 is -12. A sub 3 is going to be the previous term times 3. Previous term's -12 times 3 is -36. A sub 4 is going to be the previous term, -36 times 3. You just keep multiplying by 3, -108. A sub 5 is going to be the previous term, -108 times 3, and that's going to be -324. All right, so I have my first 5 terms, -4, -12, -36, -108, -324. What happened to get from term to term? You just multiply by 3. You multiply by 3, you multiply by 3, you multiply by 3. That gets you from term to term. That's what this definition is saying. Previous term times 3. Okay, just get used to the notation. The math is easy. It's the notation that's a little confusing. So a few more here, and we're going to do a couple in class. Determine if the following sequence is geometric or not. If it's geometric, find the ratio. Okay, well, basically you could tell that just by dividing, because if there is a ratio, you should be able to divide going backwards. So start with the last one and divide the previous term. -4 divided by 2, that's -2. So that means I must have multiplied to get to -2. Let's just check to make sure it works. Now do these two. 2 divided by -1. That is also -2. Do they match? Yes, they do. So it appears that R is going to be -2. You could do that all the way across. Just divide 2 consecutive terms, the last one divided by the one before it. For this one here, they want us to write the explicit formula. So we're going to use the formula on the previous page. A sub n equals A1 times R to the n minus 1. All right, so we're going to say AN equals A1, which is the first term, so that's 4, times the ratio to the n minus 1. Now the ratio is what's happening to get from term to term. How do I get from 4 to -2? I multiply by -1/2. Right? -2 is half of 4. 1 is half of 2. But because it goes positive, negative, the ratio must be negative. So the ratio is -1/2. R is -1/2. So I just plug that in, and here is my explicit formula for this sequence here. Now if I want to write that recursively, I'm going to say A1 equals 4, and then A sub n equals A sub n minus 1 times -1/2. I just say previous term times -1/2. And that's how you write it recursively. Okay, again, this is going to take a little practice, and we'll do it in class. And then what we're going to do is we're going to save these last 3 examples for class time, because the video is getting a little long. Plus, I want to go over this a little bit with you in class, because I know it's a little confusing. All right, so I will see you then.